Hello students, welcome to the KSMP Academy. This is the second video of the first unit. So here we are going to discuss the electric field intensity or electric field strength. So to start with, let us assume that a charge Q is placed at the originate vacuum that we are assuming. So this is the source charge. So this charge will be producing a field everywhere in its surroundings, and if any other charge is placed in this surrounding or in this field, it will experience a force. Therefore, what we say that a field has been generated, and in this field if another charge is placed, then it will experience a force. So a field is what? A field is an area or a surrounding around a source charge, where if we are putting another charge, then it will experience a force. So here Q is what? Q is known as the source charge, due to which the electric field has been generated. So Q is the charge which is generating the electric field. And if we place a test charge in this field at a position R, then according to Coulomb's law, the force on charge Q is given by this relation, that is 1 by 4 pi epsilon naught Q upon R square unit vector R. Unit vector is in the direction of the force. It is giving us the information regarding the direction of the force. So as per definition, electric field is defined as electric force per unit charge when a charge is placed in an electric field. So that means E is given as limiting case Q tends to 0. Q is a test charge. It is a very small charge, F upon Q, or simply we say E is F upon Q, Newton per Coulomb or volt per meter. Electric field will be in the direction of force, which depend on the nature of charge Q basically. That is whether the source charge is plus or minus. So E, because of this source charge Q, when we place a test charge small q in this field, by definition is given by this expression, that is 1 by 4 pi epsilon 0 Q upon R square. Again unit vector R is giving the direction of the electric field. So that's how we write the electric field intensity. So it is force per unit charge, and when small q here we are considering to be a test charge. And remember here that capital Q is source charge. It is source charge, that we should always remember. Because of it, field has been generated. So important thing is that electric field is due to capital Q, and it is independent of the test charge Q. That we should always remember. We have considered to be a test charge. It is not disturbing the field because of charge Q. For a positive charge, electric field will be directed radially outwards from charge Q. That is, you can consider, let us say charge Q is placed at this point, and at some point small q is placed. So at this point electric field will be in this direction if this is plus, and if this is minus, then it will be to the opposite direction. So direction of the electric field will depend on the nature of source charge, that is whether it is positive or negative. Magnitude of the electric field depends on the distance r of the test charge from the source, that is on r, small r. At equal distances from charge q, magnitude of the electric field will be same because it is depending on the small r. If we consider a sphere, for example, then on that sphere the magnitude of the electric field will always be same because of this spherical symmetry. Similar approach we can apply for a system of charges. That is, we are considering that electric field has been generated because of system of charges, and that is source is the system of charge having charges q1, q2, q3 and qn, and their positions are r1, r2, r3 and rn, that we are assuming. So electric field at a point in the system, as we know, is defined as the net force per unit test charge. So that means first we have to write the expression for the net force. So net force or resultant force F on test charge Q, which is located at R, will be what? It will be the vector sum of all the forces as per the law of superposition or superposition theorem. So these are the terms here. That is, first term is due to the charge Q1, force due to charge Q1. Second term is force due to charge Q2, and then Qn, that is force between Q1 and Q, force between Q2 and Q, force between Qn and Q. And remember, R1, R2 and Rn, these are representing the unit vectors, that is direction of these forces. That is, you can say that this is the sum of F1 plus F2 plus Fn. So R1, R2 and Rn, these are the unit vectors giving the direction of the force. So electric field intensity, now we can write as the resultant force F upon Q. So this will give the expression, that is E is 1 by 4 pi epsilon naught summation 1 to n and Q upon 4 pi epsilon r square, and Rk is the unit vector. So that's how we can write the electric field intensity if the source is a system of charges. Approach is similar, only thing is that we have to write the expression first for the net force or resultant force. So electric field is very important in the development of science and technology. It is an elegant way of characterization of the electrical environment of the charges. It tells the amount of force on a test charge. This is the characteristic of a system of charges and is independent of the test charge. We should always remember there are different phenomena, scientific phenomena, which are explained on the basis of this field. That is, time dependent electromagnetic phenomena we can explain. That is when charges are in motion, or accelerated motion of charges are producing electromagnetic waves. So we all know that what is the importance of electromagnetic waves nowadays. Without that, nothing is possible. So electromagnetic waves transport energy also, they transport information also from one point to another point. So electric field is very important in the field of science and technology. Now let us have a look at the electric field lines, how these are generated. So what we are assuming here, that point charge is placed at the origin and field is represented by vectors. So you see here the diagram, a plus charge we have assumed to be placed at origin, and these are the vectors which we are talking about. These are the vectors which we are talking about. These are representing basically the electric field. So you can observe that as you move away from the positive charge Q, then length of these vectors is going to be smaller and smaller. That is, it is representing that magnitude is decreasing. Magnitude is decreasing. So if we connect the arrows pointing in one direction, the result is what? Result is field line. Result is field line. And magnitude of the field is represented by the density of the electric field lines. It is important that number of lines are not important, because there may be infinite number of lines which can be drawn. So what is then relative density. So relative density is the important one, which gives the idea that how much intense is the field. Field line starts from positive charge and ends at negative charge. For a single charge, the second charge we may assume to be at infinity. That is, the electric field line may start from infinity or may end at infinity. That we can assume. In a charge-free region, these field lines can be considered to be a continuous lines. And this point is very important, that the two field lines never cross. Two field lines never cross. They do not form any closed loop. We should remember that electric field lines never form a closed loop because of the conservative nature of the electric field. So as you can see in the diagram, In the first case here, charge is positive, that is Q is greater than 0. So this is how we can represent the electric field lines. And second one is for the negative charge, that is Q is less than 0. So direction is towards the charge, that you can see. This is the direction. So that's how we can represent the electric field line. Another diagram here is for you to understand the charges. You see there are two charges placed near to each other, that is plus Q and plus Q. So in that case, this is the shape of the electric field lines, as you can think of with the help of Coulomb's law, because they will be repelling each other. So accordingly, electric lines will be rearranged, electric field lines. Second diagram is for the dipole. A dipole is what? It is an arrangement of the charges of plus Q and minus Q. That is two equal and opposite charges we are taking. So in that case, you see these will be the field lines. This will be the arrangement. You will be going to see the detailed study of the dipoles in the topics to come. So now it should be clear that how electric field intensity is written, and how the electric field lines are generated, and what is the direction of electric field lines, and how to represent the electric field lines. So thank you very much.